Today our next topic is electrical oscillator. We know that there are two types of oscillators. First one is mechanical oscillator and second one is electrical oscillator. So we have discussed four types of mechanical oscillators. Now it is a turn to study electrical oscillator. So electrical oscillator is nothing, it is simple LC circuit. L means inductor, C means capacitor. The combination of inductor and capacitor is called LC circuit or electrical oscillator. It is also called LC circuit. So you have read this topic in 10+2 class. You know that the capacitor is charged and store energy in the form of electric field, and this inductor, it store the energy in the form of magnetic field. So it is the conversion of energy in the form of electrical to in the form of electrostatic to magnetic energy and magnetic to electrostatic energy. So you know that there are four steps for this oscillator. Initially the capacitor is fully charged and inductor is uncharged. After some time this charge will transfer to this inductor. The second case, it will become like this, LC, and now the capacitor is fully discharged and this energy or this charge will shift to the inductor and store in the form of magnetic energy. Then after some time again, due to induction, this capacitor is again charged and inductor is again discharged, but it is in the reverse process. It is reverse process, or it is in the reverse order. So it is plus, it is minus. So it is opposite to this. So why it is opposite? Because in case of inductor, the induction is produced in opposite direction. Next, fourth one is in the fourth step, it is LC, and again this capacitor is discharged and this L is again charged, but it is also in reverse order. It is opposite to the previous case. And after some time, again this inductor will fully discharge and capacitor is fully charged, and it again the charging is of capacitor is in the form of electric field or electrostatic field. So it is the whole process during the charging and discharging of capacitor and inductor. So it will become a cycle, and ultimately if we see the case of capacitor only, initially capacitor is fully charged, means maximum charge, then 0, then minimum charge, then 0, then maximum charge. So we will get like this, the wave, initially fully charged, then 0, then minimum, then again 0. So this process repeat again and again. It means the vibrations or oscillations are produced in case of capacitor like this. So in case of capacitor, the wave is like cosine wave, cos wave. When we see or observe the behavior of inductor, so initially inductor is not charged and the charge across inductor is 0, and after some time it will maximum charge, then 0, then minimum. So it means in case of inductor, this is the behavior of capacitor and it is the behavior of inductor. Inductor is initially 0 and then its maximum charge after this, and after that it is again 0, again it becomes 0, then again charge in reverse direction, then again process inductor is 0. So this is the behavior of inductor. So inductor is sine wave and capacitor possess cos wave. So both are harmonic waves. It means the oscillations produced by this LC circuit are harmonic oscillations. So we will prove it mathematically, how these waves are harmonic waves or harmonic oscillations. So mathematically we will prove this article by using same the concept of deforming force and restoring force. So, here it is it can be proved by using the concept of voltage. So, voltage across capacitor is equal to voltage across inductor. So, this is the main equation in case of electrical oscillator. In the previous case, we have used the equation the deforming force is equal to restoring force, but in case of electrical oscillator, I am using the voltage across capacitor is equal to voltage across inductor. So, it is the concept of voltage. You know that voltage across capacitor, if you know that in case of capacitor, C is equal to Q upon V and V become Q upon C. So, voltage V across capacitor may be written as Vc, it is Q by C. This is first equation. So, it is voltage across capacitor. Now, the voltage across inductor, that is VL. So, what is the voltage across inductor? It is minus L di upon dt. So, you know that this formula used for voltage across inductor. So, both formulae we have read in the previous class. Now, comparing both first and second means both are equal, and we get Q by C is equal to minus dl upon dt, dl di upon dt, this one. So, it is same as deforming and it is just like restoring, but here we will use the concept of voltage. Now, change this current I in terms of charge. So, you know that I is equal to dq by dt, therefore, this equation will become Q by C is equal to minus L d upon dt of I means dq upon dt. So, it is nothing, it is L, it is second derivative of d square q upon dt square, Q by C. So, make this equation as standard SHM equation, that is from here we will get d square q upon dt square, this one is equal to minus q upon L into C. This L will go in the denominator on the left hand side. So, this is Q by LC. So, make this equation or compare this equation with standard equation of SHM. So, what is that equation? It is second derivative of charge is equal to minus omega square into charge. So, put 1 by LC, this one, this LC. So, 1 by LC is equal to omega square. So, we will get d square q upon dt square is equal to minus omega square q. So, it is equation like a second order equation in terms of q and omega square. So, this equation proves that the motion is SHM, simple harmonic motion. Okay. Now, if the motion is harmonic, then what will be the time period? So, time period can be calculated from this value omega square is equal to 1 by LC and omega equal to 1 by LC under root, this one, and omega is 2 pi by t is equal to 1 by LC under root or t. So, this implies t become 2 pi into under root LC, this one. This is time period, or if we consider its frequency. So, we know that frequency is equal to 1 by time period. You know that frequency is a reciprocal of time period. So, take its reciprocal 1 by 2 pi under root LC. So, this is frequency or time period of oscillations produced in the electrical oscillator. So, this is electrical oscillator. Next, in the next lecture, we will find energy stored in electrical oscillator, and after that we will study the next topics.